Another recording. So going back to our main function right here, let's see, we have two attempts to calculate this distance. Let's first try to build this, make sure it builds and there aren't any unsolved problems with that. So this works. So I guess I can just we can actually display those things, right? So we can say, okay, include IO stream, right, and just display cout display dist once, right? So we can just like use new line here, and then the second time. So we'll display it two times. Once called PT2, compute your distance to PT1, and the second time PT1, compute your distance to PT2. All right, save, build, and run and see what happens. All right. Oh, what's that? 0, 0. Distance to point. So the difference x minus. Let me see. So we did set everything on these two. We call distance to point. Well, let me see what's going on here. Breakpoint, insert breakpoint, and let's try to find out what's wrong. Start debugging. All right, so we're looking at the dist, which is uninitialized, PT1, PT1 set, set supposed to do this. Oh, okay. So this is an integer, and okay. Well, that's why, right? Because this is like this particular function that gets invoked doesn't do anything. So please, let's do something. Obviously, that's not good. So save that. I guess I'm gonna stop the debugging and build again. Conversion from double to int. Warnings are given because those are declared int. Well, you know what? Let's make them double because we seem to be switching to double variables. That's okay. We can do that. It's a good warning to have. So let's see what happens this time. So Control F5 just to execute. So there you go. Two times we called it, and two times we got this result, right? So again, once we called it for PT1, compute distance to the other guy, and then PT2, compute the distance to the other guy. Now let me see if I just if you look at it, like there's negligible difference in the x coordinate, like 4 and 5, but there's significant difference between y coordinates, 88 and 3. So yes, that seems to be an okay. See, it's pretty close to 88 minus 3, 85 point something else. So yes, the two work, and that sort of demonstrates the fact that not only private member variables are available to member functions of any kind, but also it's true that there is no problem in actually looking at two different objects, for one that it's called and for the other one that exists elsewhere. This function can access its own x and the x of the other object, and compute the differences for x's and y's, and then compute the meaningful distance and so forth. So does this make sense? Right? So it's again, if you have not done a lot of this programming, this may be becoming somewhat confusing, because you have this idea and you want to type some code, and sometimes it works, sometimes it doesn't work, but in this case it's perfectly fine. So that's really good news, and I think it's just the way we would expect it to be. Okay, moving on. Struct versus class, I already said that. Default access control for structs structs are inherited by C++ from C, so they're supported, and they're the same as class, but default access control for them is public. So for example, if I change this, if we know in class this is private, okay, if I change it to a struct, okay, nothing is going to happen, nothing is going to really to change. I can build this just the same way, and you know, it doesn't change much right now. But if I don't use this, by default inside the struct everything is public, right? So that's what struct makes. There is a very firm, extremely firm convention between C and C++ programmers, and C++ programmers in particular, not to use struct for anything with only public data members. If you're considering to actually, you know, if you have a struct and it has some public data members and you're happy with that, but as soon as you need to add some operations, it should probably become a class, okay? So it really has to be a class, and then, you know, we're just back to, you know, square one, where we started. So once you start adding operations, because in C, to be consistent with the subset of C, in C structs were permitted, but obviously it's not an object-oriented language, it's purely procedural language, so no operations could be given to those structs in C. Therefore, C++ programmers say, listen, structs are fine, we will use them if we have to deal with structs that have only public data members, just structures of data. As soon as you have some intelligent work done through operations, let's use class, and that's just the way it is. So moving on, so this is that kind of discussion here, and then some object-oriented programming philosophy notes here. I will postpone this discussion till the end of the class, or maybe next week, so that we can actually focus on perhaps now on an example of a constructor, and maybe we can then quickly have an example from the you know, using graphics program. So how about that? So and I can probably do this very informally, not necessarily follow